All right. So test part 1 is tomorrow for 2B. This is going to cover sections 2.4 to 2.9, everything since our last test. Part 1 tomorrow, it's over questions 1 through 7, so pretty much that first page front and back in your packet. We're going to go through those questions together today. In addition to those, you guys know you have all those extra practice problems in Polaris. Those same practice problems that I have posted in Polaris, Mrs. Talarchuk she calls it like a study party after school. She's going to have those printed in her classroom in A301, just 2 doors down, and you can go to her room to practice those questions if you want. Again, it's the same stuff I have posted for you, but she is available after school today. If you want to go there, you're welcome to. And then the same thing on Friday to get ready for Monday's part if you feel like that would be helpful. Both parts of the test are basic calculator only, except tomorrow there is one question that after you turn in the test, there's going to be a half sheet of paper that you're going to need a graphing calculator for. And that's the one, I think it's question 3. You see the little graphing calculator picture on that question on the bottom right corner. That's the question that you'll need a graphing calculator for, and you'll see why. Okay, so we'll do all of that today. All right, so first set of questions is to find the domain of a function. So what were the 2 things that we were looking for as far as restrictions go? Denominator can't be 0, and then what can't be under a square root? Negative. Okay, so the first one's a square root. So how do I solve for the domain? Go ahead. Yes, and actually a little bit more than just equal to 0. We're going to use greater than, less than. Which one? Has to be greater than or equal to, and that's just saying, hey, we want it to be 0 or a positive number. And then you solve. So I'm going to add 6. Divide by 3. Remember, in an inequality, if you do multiply or divide by a negative, what do you have to do? Flip the sign. Okay, so if this was a negative 3, I'd have to flip the sign. I don't have to here. Divide by 3, you get 2. So your domain, and all domains and ranges, even if it doesn't say so, remember we're putting those in interval notation. 2 with the bracket because it's equal to infinity. Okay. For the middle one, function g, my denominator can't equal 0. So that's how I'm going to start. Denominator can't equal 0. And then we're going to solve this like this is a regular equation, and that's going to give us our restriction. So how do I solve something like this? It's a quadratic, right? So what are we doing? Factor it. Yep. Remember, guys, quadratic, you are not trying to get the x alone unless there's only one x. If there's just an x squared. Here, there's 2 of them. So we get it equal to 0, and then we either factor or use a quadratic formula. What 2 numbers do you know that multiply to negative 18 and add to 3? 6 and negative 3. So if I set each of those equal to 0, I get my 2 restrictions. X cannot equal negative 6, and x cannot equal 3. So then imagine, if you need to do this, it's kind of like an optional step. We've got a number line, and everything on my number line is filled in, except at negative 6, I have an open circle, and at 3, I would have an open circle. So there's 3 groups of numbers that make up my domain. Everything in this problem should be parentheses. Negative infinity to negative 6 is my first interval. Don't forget your u when you've got multiple groups. Then negative 6 to 3 for the second interval. U again, 3 to infinity. Okay. The last one is kind of a combination of the 2 situations we've talked about already. So in the numerator, I have a square root. So my x must be greater than or equal to 0 from that numerator. And actually, there's nothing to solve for. Okay. Then my denominator, just like the previous problem, cannot equal 0. How does that guy factor? It multiplies to negative 14 and adds to negative 5. Negative 7 and positive 2. So x cannot be 7 and x cannot be negative 2. Okay, now there's a lot going on here. So this is again one where I would kind of recommend drawing this out on the number line. So first of all, x is a number greater than or equal to 0. So at 0, I have a solid dot, and then everything above that is shaded. That's my first restriction. Then x can't be -2. There's an open circle at -2. And there's also a restriction at 7. Anywhere that's shaded is your domain. So that extra, like -2, it doesn't matter anyway. It already can't be -2 because that would be a negative under my square root. So this group and this group make up my domain. 0 is a solid point. So 0 with a bracket to 7. 7's an open circle, so parentheses, and then 7 to infinity. Okay. Any questions on our domain problems? Okay, moving on. Number 2, using the graph to answer the question. So if a number is inside the parentheses in function notation, unless you see the little inverse symbol, it is an x. Oop, that didn't show up. Oh, there it is. Okay. It's an x. So if you're given the x, you're looking for the y that goes with it, and you're using the graph to do that estimation. So if my x is -4, that would be there. And then I just go up or down to my graph. In this case, my graph is above. So the answer for that one is 2. It's finishing that point. -4, 2 is a coordinate on this graph. When it's 0, that's there. Go up or down. Make sure you don't go to the open circle because that's not really a point. Closed circles when we're looking at, so -1. That's our answer there. C, I've just got to do 2 of them. So if I have an x value at 4, that takes me to 1. If I have an x value at -2, that takes me to -1. And then I am supposed to subtract those 2 values. 1 minus -1 gives me 2. That's the answer there. Okay. D and E are the opposite now. So notice they have an x there, and it's equal to a number. So you are given the y, and you are looking for the x. These type of problems are where you could get more than one answer. And the quiz that we did over 2.4 to 2.7 that you guys got back already, there were several people that gave me one answer, but not both. So make sure, like when we do this, if my y is 1, that's there. You look left and right. Any value to the left or to the right on that line, y equals 1 is a solution. So it looks like about -3.5 maybe. And then the other one, my line was a little crooked there, looks like at about 4. So we have 2 different x values on that graph that have a y coordinate of 1. Okay. Y coordinate of -4, well, y equals -4 would be down there. Does this graph ever get to -4? It does not, so no solution. It's an open circle, but there's not a point there when we know that, when we see that. No solution. Okay. Any questions evaluating function notation from a graph? Okay. Number 3 is the one that you guys are going to do after the rest of the questions on the test. This is the one that you're going to need a graphing calculator for. So let me get mine loaded up here. Tomorrow, I will not tell you these steps. If you ask me what button to push or you tell me I've got an error, I'm going to say, oops, sorry, that's not good. But you need to know how to do this yourself, okay? So I would recommend following along if you have not done this recently. Okay, so first part of the question, we're going to find any minimum and maximum values. Second part, then, we're going to use those minimum and maximum values to get any intervals where it's increasing, decreasing, constant. So first, I'm going to go ahead and put this in y equals -5, oh, nope, there's something before that one. X to the 4th minus 5x to the 3rd plus 5x squared plus 5x minus 6. Excuse me. I'm going to hit graph. Oop, and I'm in a weird window, so I'm going to hit zoom 6 just to see it in my standard window. Okay. So equation in y equals zoom 6 to see the graph if you don't immediately see it, and you should have a picture like this. Any questions so far? All right. How many maximum values do I have in this picture? Maximum values? 1. And how many minimum values? 2. Okay, so we're going to have to do this procedure 3 times. 1 for the max, 2 for the min. Let's do the maximum first. So I'm going to hit second, trace. This is our calculate menu. And then you're going to pick either min or max. Right now I'm doing the max, so number 4. Okay, and there were 2 ways to do this. The calculator tells you the 3 things it's going to ask for are left bound, right bound, and then guess. So left bound, you either have to type in a number to the left of the maximum, or this one's not too bad. You just take your little blinking cursor and move it so it's on the right side of that hill. And then hit, oh wait, what's it ask for first? The left bound, sorry. Left side first. There we go. On the left side of the hill where it says left bound, hit enter. If I wanted to pick an X value, I would probably pick like X equals 1. So you could hit 1, enter, and that would be on the left side of it. Either way, when you hit enter, you're going to see a line appear on the left side of that hill. That's where we're looking. Then it says right bound. So we're going to arrow to the right side of the hill, hit enter. And now you should see bars on the either side of that maximum value, and the arrows are pointing towards the maximum. So that's how you know you picked good numbers. Then just where it says guess, we're going to hit enter, and your cursor should show up on that maximum point you're trying to calculate, so you know it calculated the right thing. And then at the bottom it tells me what the min or the max is. I'm going to drag mine over here. So I have a maximum at 1.469 and 0.941, and that's a max. Okay. So now we're going to repeat the process with the minimums. So second, calculate minimum number 3, and I'll do the one on the left side first. So I'm going to go to the left side of that little valley, hit enter. Go to the right side of that valley, hit enter, and then hit enter one more time. Okay. And then that tells me I have a minimum, if I round to 3 decimal places, at negative 0.326 and negative 6.914. Okay. And then one more time. Second, calculate minimum. This time it's the little valley on the right side. So I want to be on the left side of the valley, hit enter. On the right side of the valley, hit enter. Enter one more time. My blinking cursor shows up on the bottom of that. And that point is, give myself a little bit more room here. We have a min at 2.607 and negative 1.383. Okay. Any questions, any issues we're encountering getting those values? Okay. Second part of the question now says, name any intervals where it's increasing, decreasing, or constant. So actually, I'm just going to go from left to right here. As I read this graph from left to right, is it increasing or decreasing first? It's decreasing. Remember, when you list these intervals, you only use X values, and they will always be parentheses. Okay? So it is decreasing from what to what? Negative infinity all the way to, what's that first X value, that minimum that we hit? Perfect. Then it turns around and starts increasing from that number, negative 0.326, all the way to the maximum point, which was 1.469. Then it turns around and decreases again from 1.469 all the way to the other minimum, which was 2.607. And then finally it increases from 2.607 forever, so to positive infinity. Yes, Grace? 3 decimal places is going to be like a general rule. So if something is not, if you don't have instructions as far as rounding goes, just 3 decimal places always. Yeah. Okay, so that's the graphing calculator question. Any questions on that one? All right, on the back side. Number 4, we have graphs, and we are determining if they are even, odd, or neither. If all you have is a graph, the only thing that you can discuss as far as like proof as to what it is the type of symmetry. So when it's even, what kind of symmetry does it have? If a function is even, what kind of symmetry do we have? Y-axis. If a function is odd, what kind of symmetry does it have? Origin. And that one is the one that's going to look like a rotation of 180 degrees, flipping it upside down. So those are the two things we're looking for. Can I mirror it over the y-axis and it look the same? Can I flip my paper upside down and it look the same? And then if neither of those are true, it's neither. What do you think about the first one on the top left there, my little W shape? Even, odd, neither? Neither. And if you had to explain, which you are going to have to explain, I would say no symmetry to y-axis or the origin. Okay. What about the one on the top right? The two U's. So yes. So if it's origin, what kind of function is it? Odd. Okay, so we're going to say odd, and then our explanation is symmetry to the origin. That's the one where you guys can see. If you flip your paper upside down, the picture is going to look the same. Symmetry to the origin. Okay, and then what about the one on the bottom there? This one has symmetry. Even. Oh, I thought it said neither. It is even. Yes, okay. And what's my symmetry? Y-axis. Perfect. Okay. Any questions on those? All right. Number 5, given a piecewise function, we are just evaluating the function. So remember, the hardest part about these was just knowing where to plug that x value in, which piece works. So if my x, well, actually here it's not an x, it's a t. If my t is -2, which piece do I plug it in? Top, middle, or the bottom? Yeah, the bottom is where -2 is defined, where I'm allowed to equal -2. So I'm just going to do -2 cubed on top, and then -2 plus 9 on the bottom. That's -8 over 7, and then that does not reduce. So we're just going to leave our answer like that. -8. If t is -8, which piece do I plug it into, top, middle, or bottom? Middle. So -8 plus 19 will give me 11. And then -13 into the top. Be careful with this one. -13 squared, I know, is going to be a positive number. It's 169 plus 65. So what does that give me? 234. Okay. Any questions on 5, evaluating piecewise function? Okay. Number 6. Okay, so this one, you need to know that parent function, basic function chart. You don't need to memorize the whole chart. I would say, like, bare minimum, what you guys should know is the shape of every type of function that's on there. And if I were you, when I got my test tomorrow, the first thing I would do in the margin is I would just draw all my shapes. Because the shapes, then, you can look at one of these questions and name which of the following are odd, or which are even, or which one have a y-intercept or an x-intercept, or what quadrant. Every piece of information you can get about a function is from the shape of the function. Okay? So, odd functions. I don't care if you give me the name of the function or the equation. Either one is fine. What functions from our parent function list are odd? So symmetry to the origin. X cubed. Yep. What else? Y equals x, our identity function. One of the roots. Cube root. What else? There's at least one more. 1 over x, our reciprocal function. I think that's all of them. Yeah, I think we're good. Okay. Part of the graph is in quadrant 3. Well, all of those ones we just listed have something in quadrant 3. What else? Let's just kind of run through the parent functions. X squared, no. X cubed we got already. Y equals x we got already. Square root in quadrant 3. Cube root we got. The reciprocal function we got. What about 1 over x squared? That's only in 1 and 2. That's where the branches are both on top. What about the exponential function? That one looks like this. No. What about logarithmic? That one starts at the bottom and curves out like this. Quadrant 3. No. Absolute value? No. Ooh, what about my greatest integer function, the step function? Little stairs? Yeah. Let's add that guy on there. That one looked like a bracket with an extra little line on it. I think that was all of them. Okay. Has a y-intercept at 0, which is a fancy way of saying it's going through the origin. Okay, so the ones we have all there already, right? Again, y equals x, y equals cube root x, y equals, actually y equals 1 over x doesn't, right? Because what does that have? Has asymptotes on my axes. Yep, so if you're asking something about asymptotes, both 1 over x and 1 over x squared have asymptotes at the x and the y axis. The other two functions that have asymptotes are your exponential function, doesn't touch the x-axis, and your logarithmic function, your log function, doesn't touch the y-axis. So there's 4 that have asymptotes. Okay, cube root, the step function. What else touches 0, 0 that we haven't listed? What else? Absolute value. What else? Square root. What else? Squared. Log doesn't. Exponent doesn't. I think that might be all of them. Okay. Make sense? Kind of what you need to do with that one? Okay, good. All right. Last one, this comes from section 2.7. This is that big chart that has the A, B, C, D with the rules in it. So if you need to make flashcards or something for that, make sure you do it. The one thing I would say, and this was a very common mistake on that first quiz we took, is remember there should be nothing in front of your x. If there is something in front of your x, this is the absolute first thing you should look for in these problems, is you want to factor it away from the x. It's still going to be, like in this problem, inside the absolute value, but it's going to change that left-right shift. So if you missed the left-right shift part of that question on the quiz, it's probably because of this. Okay, so what does a negative outside do? We're just going to list these transformations. Negative on the outside is a reflection over the x-axis. What does the 1/4 on the outside do? It's multiplied. It is a vertical, because it's on the outside. Shrink, or you could say compression, because it's a number smaller than 1. If it was 4, it would be a vertical stretch. What does the 3 on the inside do that's multiplied there? Go ahead, one.
Horizontal shrink.
Yes, this one's the tricky one. It is a horizontal shrink. So if you needed to put numbers on these, vertical shrink by 1/4, the horizontal shrink is by 1/3. The horizontal stretches and shrinks are the ones that I said be careful about. We use reciprocals. So if I saw a 1/3 in there, in front of that parentheses, it would actually be a horizontal stretch by 3. Okay, that's when we use reciprocals. The +3, if it's adding on the inside, which direction does it move? Left, and then I want you to say how many units. Left 3 is good. And then finally, the -5 at the end, down 5. Okay, The next one, I have again something to factor out. That negative needs to get away from my x. It's still inside the cubic function. I just pulled it away from my x. All right, what does the 2 out front do? Vertical stretch, and you could say by 2. What does the negative inside the cubic function do? Reflection over the y-axis. Okay, the -4 on the inside moves it which way? Right? 4, and then we're going to go up how many units? 3. Okay. And that's the first part of your test tomorrow. Okay, so tomorrow you're going to do those 7 questions. We do have a shortened period tomorrow, but as you can see, it's a shorter test, so that should be no issue. And then on Friday, we're going to go through the rest of the study guide. So again, I would encourage you to try them on your own first, and then just use your time at home when you're studying to use those extra practice questions as needed. But that's all you got to worry about for the next like 4 days or whatever. Just study and getting ready for both parts of this test. Okay? Questions for me? All right, so I'll do cell phone lotto. Last 20 minutes are yours. I'm going to pass back quizzes from yesterday. Make sure you get with your partner so you know what you missed if yours wasn't the one that was graded. And then you can keep those and use those in your previous quiz to study with. All right? Okay, great.